Hello everyone. Today, today I will be discussing about EventStoreDB. So before proceeding, I will cover the basic concept related to EventStoreDB and let's discuss about the knowledge etiquettes. First one is punctuality. Join the session 5 minutes prior to the session start time. Be start on the time and conclude on time. Second one is feedback. Make sure to submit a constructive feedback for all sessions as it is very helpful for the presenter. Third one is silent mode. Keep your mobile device in silent mode and feel free to move out of the session in case you need to attend any urgent call. And last one is avoid disturbance. Avoid unwanted chit chat during the session. For our agenda for this session is we will cover the topics. First one is events, second one is event stream, and third one is event sourcing and what is event store, and at last we will discuss about event store DB. So let's start. What is an event? Can someone tell me what is an event? Actually, I think most of us are using event sourcing. So few of us have an idea about what is an event. Can someone tell?
Okay. Yeah, an event is an action that being generated by an application that need to be captured by another target application.
Okay.
Maybe some devices also generate events, right? Sensors, they also generate events.
Okay. Right.
Something that happened, right?
Yeah.
That's all.
Here is an example of an event. And there are five events which are shown here. All these events are related to a placing a order. So let's discuss about what is an event. So event is a representation of an fact or event represent a fact of information. So it gathers the information about something that happens in past, like mm, in Sunday there was a match between India and Pakistan. So that was an event. So event has certain information like at which time, who won the match, who were the team members, who dropped the catch, who won the best. All this all this is the information related to that fact. And events are immutable. So immutable means we cannot change it. As we cannot change our past, so we cannot change any event. Event can be ignored but cannot be withdrawn. Here withdrawn means can what has been seen cannot be unseen. So like in same example, uh, we cannot deny that who gave maximum run, who dropped the catch, or we can ignore that who was the cameraman in that match. So event can be interpreted differently. So by taking the similar example, there was two teams. One won the match and other lose the match. So winner interpreted that differently as compared to the loser one. Winner will be in happy mood and loser will be in sad mood. Uh, Events are the messages, which is quite critical to why we are gathered here. So these messages might be stored in any format like JSON, relational table, binary, or a disk storage. And let's move toward the example. This is a screenshot of the code camp which is conducted by Ravindra Dua. So who conducted it? What was the time? Who were participating in that event? What was the duration of this event? Why this event was conducted? And let's move toward the next topic, that is event stream, which is also an important topic. So what is an stream? Can someone explain or just can give an idea related to what is event stream?
Okay, a stream is a continuous flow of data
Right,
from a source system.
right. So here is an example of that stream. All the events are interlinked. They are in a continuous flow. So event stream is a ordered sequence of events. So why this called as stream? So streams means a continuous flow of event. So for an example, if our system is alive or in a working state, then streams between the previous state and the current state, probably a new event is recorded. If this not happened, then there might be two cases arise. First one is no one is using our system, and second one is there might be some serious issue with our system. So that's it called a stream. And streams are also immutable. So as we know that events are immutable, so stream is formed using the event. So we cannot delete event what that happened in past. Event streams are similar to real life. So for example, if we want to modify or revert any changes, then we need to trigger another event to fix it. We cannot fix it. For example, like in case of invoice, if a wrong address is mentioned in that invoice, so we have to generate a new event for fixing that address. Event, oh, this is cover. Event represent a separate object. So here in this example, a separate object is represented with five event. First one is order placed, second one is product added, third one is also product added, fourth one is product removed, and last one is order paid. So in similar pattern, we can also have a uh, another object which might have order place or product added or order place, which might have only these three: first, second, and last one. So in classical way, we can say that a stream is a one record in database. So but due to events, we have to maintain our data, means there is no loss of data. But in traditional world, only the last record or the last state is stored in the database. So event stream follow append only log. So what is an append only log? So here append only log means events are always appended to the same storage, means events are always added to the previous one. Like first one is order place, then it second one might be order edit, but reverse process might be not possible. So it also maintains the global ordering. And next one is event sourcing.
Kuldeep, can you go back to the previous slide?
Yeah.
Okay, when you say event ordering, like, are you saying that event should come in order to for a particular workflow, or like you're trying to say that if one event is generated, then eventually the second event will also get generated as by virtue of the workflow of that application.
uh, the second generated event might be different one, but the ordering of these two event will be same.
Okay, okay. I'm still trying to understand sequencing of event means like when you are, for example, you're placing an order, or like the match example that you took, like India versus Pakistan. So event begin, like the Pakistan India match begin. The toss happened. The
Okay.
toss happened is another event. Like
Yes.
now India choose to field or bat first. That is another event, right? So
Okay.
that is a sequence of events you are saying, right?
I am trying to say that a match cannot happen before the toss. First one is we have to coin the toss, then match happen.
Right. Okay.
So
So you're
this maintains the global ordering. Like in every match, first one is coin will be tossed, then match will be happen.
okay. It's clear now. It's clear now.
And as well, can we say that it's a stateful, like every current event depends on the previous event. So
Might be. Like in this case, here we have third event, that is product added. So product added can be replaced with another event like product remove. So it is not fixed that product added will be comes at the third place, but these two are fixed one for a particular event stream.
Okay.
yeah.
Okay. Good. Good. I got it. Yeah.
Next one is event sourcing.
Hmm.
So can someone give an idea about event sourcing?
Looks like from where the event is generating, source of event.
Yes, yes, yes.
Yeah.
So
Like truth, true, the truth, source of truth. Sorry,
yes,
you've
yes, yes,
mentioned.
yes. The terms event sourcing comes from the fact that events are the source of truth. So it also it contains the order history of our operation. For example, in previous case, when we take an example of shopping cart, then we have to firstly initialize the cart, then product edit, then product remove, and then finalize. So in this case, in classical way, when we try to add any product and then remove that product, there the loss of information, loss of data took place. So when we add any product, then cart value or product count will increase to 1. But when we try to remove the product from that cart, then product count will decrease to 0. So we cannot mm, get that whether we have added product previously or not. So this was the case of classical way, but it is removed from the event sourcing. So and nice thing about event sourcing is that we can do time traveling. Like in the like when we try to debug or test, then we can get the event from the testing system and production system, then test the result what is going wrong or right to our system. So all these are possible through the event logs, as logs are maintained. Uh, Next one is for any changes a new event is appended. So in this case, in event driven architecture, implementation is quite easy and make it possible to publish event whenever a new state changes or whenever a change in a state occur. Next one is we can put system in any prior state. So in this case, as we maintain uh, history of the log, or we can say that event log. So with that event log, we can go to any previous state of our event. So
So, Kuldeep, just a question here. Can put system in any prior state means like we can go back to any previous point in the system, right?
yes, like for example, cricket match when
Mm.
we tossed a coin. So
Mm.
this is a any state and playing match is another state. So if we are playing match, then we can easily get it from event log that the prior state was coining the toss.
Yeah, yeah, got it. Got
Next one is avoid the object relation impedance mismatch. So this case generally happened with when the database model and programming language varies. Like in some case when we choose another programming language which we are using, so this case arise. So but here we consider event, not domain. So this case all this problem also get resolved, and we get reliable audit log. So in this case it provide 100% reliable, as we know that event logs maintains all the history of a particular event sourcing, so it also get 100% reliable audit log. So it is easy to migrate. So in this case, event sourcing business logics consist of loosely coupled business entities that exchange events. So this makes a lot easier to migrate from any monolithic application to microservice architecture, and easy to determine the state of entity. So similar case that through event log we can easily determine the state of entity. Now here is a example. Here is a order table or order database, or we can consider an order event stream. So here initial state is pending one. We have to pay total $200. So initially we haven't paid any amount. So outstanding is 200 only. But when we are using relational database, so we simply update the status, and total amount to be paid will be here, then outstanding will be 0. But in case of event sourcing, we have to trigger another event which is known as order payment receive. In this case, whenever we made any transaction, so a new event automatically triggered. The best use of this event is that we can roll back from this stage to this one, but in previous one is not possible. And how can we roll back? That here the order number is this 1220. Order number is same, so we can easily find that order number. Then current status is paid, so we already know that if we pay any amount to someone, then status will change to paid one. But before that it was unpaid or pending one, so status will be pending one. So total amount to be paid was 201, so it should be remain same. But amount payment amount is 200, so this says that amount paid was 201. So initially it required some amount, so outstanding one be 200. In this way we can roll back to the previous state.
Okay, very good example. Can you go back one more time to the
Yes.
so this is where, so what you are saying is, say in event sourcing or like event, say while saving the records in the database when you are dealing with the events,
Hmm.
this order payment received should be saved somewhere else as an event and the table will be updated. Are you saying that?
uh,
I mean, will the order table be updated with their status from pending to paid?
no, no, no,
However, there will be a separate entity.
this one is separate event occurred.
Okay,
This one initial, then a new event occurred, then a new then another event which is after the order payment received occurred. So it maintain log, but it was not happening in a classical approach.
I got it. So you are saying in this picture there would be three events. One is
Yes,
for this one, the previous situation.
yes, yes,
Second is what happened, the payment came. Third is what is now the final event, which is like the state changed from pending to paid.
yes.
Okay, okay,
Next one is event store. So event store is a database of event. So it might be any database like Postgres or EventStoreDB and many more. Like Graph1 is also a database. So it also it has an API for adding and retrieving an entities event. This will be we will show in demo part, and it also store the event log, so history will be maintained. So it is quite different from the traditional one. So in this database, event store database, so all these event will be stored separately. Next one is event store DB. Event store DB. So can anybody have an idea about what is an event store DB?
database where we can store events. Store DB.
Yes, right.
Okay. An append only store DB that's store all the state change within this system or application.
Okay.
Yeah, could be like, see, what I could understand from Kuldeep is like events are coming in sequence, like one after the other after the other. So keeping a record of all those events in a store is wherever like we are storing in a DB is should be called as event store DB.
Yes. So event store DB are specifically designed for event storage, and they are used for event sourcing only. It supports mandatory operation related to that particular event, so it is simple to use. And it also as I told that is stored data in the forms of events, and it designed to prevent data losses. As I in earlier example, as I told that event sourcing used to prevent data losses by the example of that order one, and it stores an immutable series of events. As we know that events are immutable, we cannot change events, so the data which is stored in event store DB must be immutable. And event stored DB is available in two forms or two types. One is open source and second one is enterprise version. Enterprise version provides some additional features, and as additional feature something like that, we can get event sequence visualization, but event sequence visualization is not available in open source one. So this one is a major advantage of event store DB enterprise. And here are some features of event store DB, and first one is it guarantees rights. So as in event store DB, rights are committed to disk, so it stores the data in the disk format, so we make it ideal for source of record database. And second one is higher availability. So whenever we store any record in that event store, we can configure it as per our cluster requirement. We can make a cluster of node as per our requirement. So configuration of event store DB is possible. So next one is projection. Projection allow you to event as they are written. So we will explore projection later on. And next one is client interface. So client interface, here interface refers to the client SDKs, which is based on gRPC framework. So gRPC framework support various languages like Java, Go, Rust, and two three more like .NET also, and Node. And it optimize concurrency check. So it optimize concurrency check whenever any events failed, then server throws an exception that you can fix it or you can trigger a new event, as fixing is always done by triggering a new event, so we have to trigger a new event. And great performance dash skill, as we know that performance basically depends on the configuration and use pattern, but event store DB has a benchmark that 15,000 writes per second and 50,000 reads per second. And it also has multiple hosting option means here that it can we can run it on Windows, Linux, Mac, and cloud also. And it also provide commercial support plan. So in that commercial support plan we can get the commercial version, and various range of operation tools. And as we know that immutable data stores, so event store DB always store immutable data. These are the features of event store DB. And next one is what is projection. This one is quite important. So can someone tell what is projection? Just an idea related to what is projection.
No.
Projection is a combination of all the events that was stored in the event store database to aggregate. It's like more of like aggregation.
Okay. Anyone else?
So projection probably is what we want to source out of this, the event that we have. So like we have like 10 fields, but we
Mm-hmm.
want to, emit only like 6 or 8 fields out of my. So
Mm,
yeah,
so
so that is
can I summarize here that you are trying to say that it's a view-like structure?
yeah, correct. It's a view can be
Okay.
related.
Okay. Can someone tell that I am presenting? Is there any projection going on?
I didn't want the question.
I am presenting this slide. So can someone tell that projection is going on from the side of participant?
Like
Yeah,
predicting,
obviously.
you have multiple things on your systems, right? But you are only presenting only your slides.
Okay. And can someone tell that another scenario that I am thinking a scenario that there are I don't know how many participants are there, around 12 participants. So someone are from Java Studio and someone are from different background. So from those who don't know about event store or event sourcing, they have a different interpretation about this knowledge. So they think that it might be useful or maybe used in future, so let's have some get an idea about what's going on. So this may be a projection because projection is basically depend on interpretation. So some information, same information but different interpretation. So
Okay, so I could understand is like, see, from the events, we can see that the example that you took, for example, somebody ordered something and then he placed the order and then paid it also. Now we can think about like this customer is actually buying so much of stuff, so he can be given opportunity for certain discounts. So we are kind of trying to project some additional information from the way he is buying the stuff. Is
uh,
that you're trying to say?
it can be the next step after the projection. Projection
Okay.
here means that we are viewing something, viewing like interpreting something. So
Okay.
it projection are used to create some materialized view of event. Here
Oh, okay. Okay.
materialized view means that card initiated or place product edit or username changed or card confirmation, all these are the part of a any event stream, or we can say subset of event stream. So they create a new record and which is named as user card dashboard. So this record is stored in database. Record is in the record can be in any form, like in form of relational DB or document DB or graph or anything. But in case of event store DB, it might be in uh, it it will be in form of file. So it follows the left fold manner. So here left fold means you can see this example. That first one is card initialization. In this case, card initialization will uh, maintain the product count to 0 and open and change the state to open one. And second event, when we add product add, then product count will increase to 1 and status will remains in open state. But we confirm card, then product count will remain 1 and status will change to confirmed 1. So this left hold manner means that we are taking a current state and applying event after event. So these events are applied to it. What event?
So do we have to configure this in event DB store to achieve this?
No, no. These are automatic projection. These are some basic projection which are on default.
Okay.
So we can configure as per our requirement, but I haven't explored that much. But I have gone through the default one only.
Mhm.
Uh, may update
So
multi.
the projection is the projection the projection is the final state of the event based on various event that is being aggregated together.
Yes, we can say that projection is a final state after the combination of subset of particular stream.
Okay, so the projection is like, if you know, in our DBMS, what we do in our DBMS, where, you know, for our DBMS or non event store database, we always update table, right? So this represents what we used to do in our DBMS internally, but we still have all the all the event that make up the final state.
I haven't got the question.
No, I'm asking that this table, this final state is like
A
what we
record,
have
record
used.
in a database.
Record, yes.
Uh,
Yes. Is that what we are going to be using to display to the user or something like
yes, yes.
that?
We can use it for further implementation or further processing of the.
Okay. Thank you.
Okay. And particular event can be handled by multiple projections also. But in when we work on relational database, then we always get confused with foreign key. That when we try to update any table, then we we think about that this might affect this table. So there will be a foreign key concept which always um, plays an important role, but it always create a headache. So we have to firstly think about that which one will be updated. But in this case, we will only think about these events onward. That next event will be this one. So particular event stream uh, projection may create a new event. Like in the previous case, mm, when order got confirmed, then we can create a new event that card finalization. So projection can create a new event, and this one is multiple read model. I think it may not be clear. It can be cleared by example that here when we try to uh, update username, update any card value, then it might update user card dashboard or card table or product availability. So one event may affect multiple. So uh, we will this image is quite blurry, so I will try to explain it. So event store position plays a role while we are um, working with subscription. So a particular uh, here we can see that shopping cart 1 and shopping cart 2, these are the two streams which are in particular order. So we can say that append only log is maintained here. So for a particular stream, the position is auto incremented. So it is clear here that first one is shopping cart, then its index its position is first one, then add second one, then add it to shopping cart, then third one, then shopping cart is stopped or completed, then last one. So here positioning is maintained, but when we store all these event stream in relation database, actually relation database stores the event streams in ordering in global ordering. So but all the events happening in particular order, and these are not affecting to anyone. So here when we try to store this event, then this increment may have a gap. When we try to remove any product or add any product from the cart, this might have a gap. So uh, this all stream shows that it follows the append only log. So how subscription happened, I am taking the example that if these three event are already processed and we know that the process position is 130, Like in case of Kafka, we have to specify some offset which is used for subscription. So if you like to subscribe it from here, then you have to specify this index and subscribe it to the last one. So why subscription is needed? So in this case, when we try to subscribe anything, then we firstly have to get subscription is helpful that it tells that these events are already subscribed, so we do not need to proceed it again and again. So like these two events are already subscribed, so we do not need to process till position number 130. We have to process it from, if we want to process from starting onwards, then we have to subscribe this from the initial state onwards. So in this way subscription is helpful. mm, Here is a difference between event store DB and relation database. So in streaming data, event store DB subscription give you a real time changes, and in relational data can be overridden, needs verification. And event store DB efficiency, so here changes are saved once, and subscription propagate these changes instantly to the needy one. That there we can configure subscription is is of three types. So we can configure is using event store config. And in relational database, data needs to be recorded, then change push out to the system. And in case of service autonomy, start and stop self-validating streams are needed and need to be revealed gracefully in a line with other system. And it follows the event driven architecture, so it might be a complex workflow and react in real time. And all solution needed to consider the different forms of data, and these are the remaining one. And let's move towards the demo part. Saurabh will present the demo parts. Saurabh, could you please share your screen? Hello, Saurabh, are you there?
Good evening, everyone. Today we are going to discuss a normal sample repo that is defined on EventStoreDB. So here is some sample repo, a repository for event sourcing JVM. Currently, we know that the event sourcing or EventStoreDB can be installed on local instance as well as on the cloud instance. But apart from cloud, we just today explore more on local instance. For local instance, we have Linux or Windows system where we can install, as well as we have uh, Docker also. On the Docker image, we can able to install the event store DB and configure it. So quickly, we just go through our Docker configuration for event store DB. So this is my Docker compose YAML file where I have configured the uh, event store DB and running one normal Spring Boot application through which we are going to communicate with our database, that is Postgres, as well as through some various events which are making some changes in our database. So let's begin with the event store DB configuration. So here is the image, that is the latest one, 21.10.5. So so as you know that we have to define a cluster for the event store DB as it have a high availability. So we have to set some data as well as some processing instance for that cluster. So today as we are running on our local instance, so we have defined just one, that is a cluster size is one, and we have to run the projection according to all the source entities. So we define it as a all, and we are also enable the all the standards projections as a true. And this we define one port, that is 113 for external TCP configuration or for event store DB connection, and the port number 2113 for interaction with the our local event store DB server. As well as we have defined the secure communication through TCP communication through and uh, uh, publish over HTTP. True. We have defined the ports over here for external as well as the UI communications, and define one volume to store a database or to define its internal work, and enable the network for event store DB, as well as below the event store DB configuration there is a Postgres configuration to store a database or store some internal values in our database. So this is its image, the container name. Again, we have defined one another container, the Postgres password, the port number where we are communicating with the Postgres services, the network. Also, we have defined the Postgres admin for a user login purpose in the Postgres server. So we have defined its email ID, the username, and password is already defined in above. So these are the volume where we are storing the data, as well as the server port where we are going to access the Postgres services, and the network configuration, and the bridge or the driver that we are going to communicate with the event store and with the Postgres, that is a bridge driver. So let's begin. Our application is up and running, and we are communicating with our application through some web services that are defined in our application, which will access to our database. So let's begin with our services. So here is the Swagger UI for our applications to get the card details, as well as the all the links that is we are going to explore further. And this is the event store DB that I have logged in, and as you can see it over here, we you can define you can able to explore all the streams over here, and this is the Postgres database that we are using in background for storing our data. These are some initial documentation as we have gone through for installation and all the documentation purpose. So consider this example. So in this slide, we have placed one order, add some product, and order paid status. So we are going to we have already created some orders as we know that we don't want so much time for uh, presentation or to explain all the details. So we have already created the cart ID or the cart and the client ID, through which we are going to communicate with our uh, storage as well as with our application. So as you can see, I have defined this cart ID V5E and ending with the PDO. So it contains only the cart ID and client ID, and status is pending, and it doesn't have any product. Also, we can explore all the orders or cart over here. We have defined one service over here. So for this cart, this client ID has been associated, and its status is pending, and we haven't added any items in our cart. So this is the URL. So sorry, this is the actual data for related with the cart ID, and you can get all the details over here from the cart ID. So let's create an event to add an item in our cart. So we create an event uh, with the Steam ID, that is shopping cart, ending with the cart ID, as well as we have to define event type. Like there are some various events. Uh, so we have to define what event is. So we are adding some items in our cart. So this is the uh, our event type, that is a shopping cart event, product item added to the shopping cart. This is the event. adding this data, or you can consider as a payload uh, uh, in the reference with the RabbitMQ event streaming. So we have just uh, created the structure for the new event, and we added event in our configuration. So uh, as you can see, so new event is over here. So event 0 is the shopping cart is open, and now we have created the uh, now we have performed one event on the same cart ID for adding a data or adding a product in our cart. So initially we have just only shipping cart and client ID in our event store, but over here we have added two items in our two product item in our cart, as you can see over here. So if we go to Postman and hit the same call, so you can get the added items, product items over here. So again, we define one new event for the same item. So this is the stream ID, the same event. When we have added 10 products for the same item, and we have added a new event in our event stream. You can able to view the stream or live streams from your dashboard also, like what storage and what jobs were triggered and what workers were working on the same thread. Also, there are some many factors like projection core and other storage projection and everything. So you can explore it over here. So we just go through our next projection. Uh, so this is our recent stream. So it has two stream version. Earlier it contained only one product. Previously it has only one, and the last contained the addition of all the three products. So
Saurabh, sorry to interrupt in between, but we have already passed 5, so if we can
okay,
close
just one.
the session
Okay,
soon.
just 1 minute. So
Sure.
these are the events that we have created. So again, all the product has been added to our cart, as you can see it in our product array. But this its status is pending for uh, a checkout. So if you go over here, so we can just able to explore it over here. The status is pending, the total price and the items. So again, we define one create one event to confirm the shipping cart. So uh, so event is just to confirm the shipping cart that we have purchased and added some items in our shipping cart. So we just created that event. So if we go through the event store, so uh, reset. Refresh it. So recent event is, or a recent stream is that we have confirmed the shipping cart. So over here we are able to see the confirmation for the shipping cart event for the same customer or the cart ID over here. But as you can go back and view this event, so you can able to see all the details for these shipping cart, that is event is occurred for the confirmation. Also the event is two times occurred for its addition of the items in the shipping cart, or addition of product in the shipping cart. So you can able to see the confirmation or the status change for confirmation over here through this URL for getting the orders status. So that's it. Like every time when we any event occurs, so it will change the status and store the historical data in the event store DB. But at the database side, it will show the updated result. So that's it.
Wonderful, Saurabh. The demo was beautiful, beautiful. Like I have seen it for the first time. How like everything is like getting recorded. How every event is like being recorded, and you can see all of them in one go shot. Also, so wonderful. Like I really liked it.
Sir, to be honest, we haven't got enough time to explain all the events like
No,
internal
no,
working.
no. Whatever you could explain, I really liked it. I must say, and I'm not bluffing even. I really liked it. Uh, Wonderful demo, guys, and wonderful explanation, Kuldeep. The previous like when you were explaining the concept, so that was also good.
Thank you.
Thank you everyone for your wonderful session. Uh, yeah, if we all know that we are running late, so probably we can close the session with an understanding that when you will be using an event sourcing architecture, you would be trying event store DB as well. Cool. Thank you everyone. Thanks
Thank
Bharti
you.
for arranging and facilitating it. We are good for the day.
Thanks, Ravinder. Thank you.
Thank you,
Thanks,
everyone.
everyone.
Bye